Hi Shreya. Right, here we go. A uniform plank AB of length 5 meters and mass 30 kilograms. Now it's uniform, so its mass is evenly distributed throughout the whole system, so it's right in the middle. I'll draw that first of all over here. Okay, A to B, and it's 5 meters. Mass is 30. It's uniform, so I know it's right in the middle there, and that'll be 30 G to make it a weight. Rests on horizontally on spots at C and D, where A and C is that. So I've got a support here. I know that's 1 meter, and because this was 5 meters, I know that that is 2.5 from there, so that's 1.5 left, and that is pushing up like that, and A to D is 3.5. So that's 2.5 and an extra 1 is there. Okay, so there's a 1 there to that point there, and that's pushing up also like that, and that is C and that is D. When a particle of mass 14 kilograms is attached to the rod at point E, the magnitude of the reaction C is equal to the mass. So I know that I can now call this, I don't know, R, and that R means that these two are equal. And it's 14 kilogram mass. So because you've got this going down here, and it's closer to this, I'd hazard to guess it's over this way here, but it doesn't matter where you put it. Okay, it doesn't matter where you put this E, because it's measured from a point. I'm going to measure it from here. So I'm going to put it over here, and it is what do we say, 14 kilograms, so it's 14 G. Okay, attach the point E, and that's point E just there. Calculate the magnitude of the reaction. The magnitude of the reaction at C is equal to the magnitude of the reaction at D. Find the distance A to E. Now, because we're going to find A to E, we're going to set that distance there to be X. And the first thing I'm going to do, because these are equal as long as this is in a certain position, is I'm going to resolve vertically upwards. I'm using net forces, and because we're in equilibrium, I've got no acceleration, it is equal to 0. So I've got basically 2r minus 44g is equal to 0. Therefore, r is simply equal to, throw that over, divided by 2 is 22g. So we've got the reactions, they're each 22g. Now, to save all problems, I'm not going to choose to take it anywhere else. I'm going to take moments here, because that will give me a nice easy way of getting x. So the next thing I'm going to do is take moments, and I'm going to say clockwise is positive around about A. Now you must remember, you're doing the sum of the moments. Sum of the moments is equal to 0 because we're in equilibrium. Okay, because you're resting in a horizontal position. So don't forget the equal 0. That's the important thing here. So if I just pull it across a little bit, give myself a bit of space. If this is the pivot point, this is going to want to rotate it around clockwise. So these two are both positive. So I'm going to do those two first of all. So here we go. The first one is we'll look at the 30g force multiplied by its perpendicular distance to the fulcrum is 2.5. Another positive moment or torque is this one here, which is 14g multiplied by its perpendicular distance, which we were told is 3.5. Now this and this are both negative, so negative, and we know r is 22g, so it is 22g multiplied by its perpendicular distance, which is 1. The other negative is the other 22g, and it is multiplied by its perpendicular distance here, which is, just looking at that, 3.5. So I've done that wrong there. My bad. It's 3.5 there. Sorry, the 14G is measured as X. Okay, X. Sorry, and this is the one here. That one there is 3.5. Sorry, I hope that's cleared. That's 3.5. Okay, and we know the sum of all these moments is equal to 0 because we're in a horizontal position. So all I did was the 14G I stupidly measured as 3.5. It is actually measured as X. Okay, and it's the 22G, this one here, that's 3.5. That's all I did correct. Negative moment, positive moment, positive moment. Working these out, you've got 2 times that is 60, half of that, so it's going to be 75. So 75G plus 14X G minus 22G minus 3 times that is 66, plus half that is 11, so that's going to be 77G. Okay, it is equal to 0. Now I'm going to divide through by G to get rid of all of these and rearrange it to give you 14X is simply equal to that 22 add 77 is 99. So I've got 99 when it goes over, take away the 75 when that goes over, all well, not yet. Therefore, X is simply equal to 5 to 80, 15 plus 9 is 24. Is that right? Oh, it's too early in the morning for me to think. 99, take away 75. I'm embarrassed, but I can't be bothered. It's 24 yet. Divided by 14. Okay, so that's what X is, and divided by 14, and you end up with 12 over 7. So I'm going to put 12 over 7, and then I'm going to round it to 3 sig fig because G was used. So SD gives you 1.71 meters. 1.71 meters from A. Okay, I hope that makes sense. Now, if you put this over here, it doesn't matter where you put this E. I'll just come back to it just to show you. I could put the E there and got it totally, it wouldn't make sense, but I'm going to put it there, 14G, and you're still measuring this to be X. It is still a positive moment, so still maths would still push it to where it needs to be, which is 1.71 meters. So 1.71 meters, it's actually not far from what it said it should be. To balance this up, actually, it's not over here because you put it over here, and you can see that it would make this less and less, whereas these two are equal, so it had to lie in between here. So you can see it doesn't matter where you put it, because we're setting X measured from A, no matter where you just draw this in, it still works out, the math still works out, comes out in the wash, as I said. Okay, I hope that kind of makes sense.